In this video, we are going to talk about how to graph polar equations. So graph the equation r equals 1 plus cos theta. Anytime you are given a polar equation to graph, the first things you must look for are the symmetries. And there are three major symmetries that you must look for. And that is symmetry about the polar axis. That's the first. The second one is symmetry about the pole. And then the last one is symmetry about the line pi over 2. To find symmetry about the polar axis, what we do is that we look for r of minus theta. If r of minus theta is equal to r of theta, then that equation is symmetric about the polar axis. Then now, to find symmetry about the pole, we will have to look for r of theta plus pi. If r of theta plus pi is equal to r of theta, then the graph is symmetric about the pole. Then to look for symmetry about the line pi over 2, we need to look for r of pi minus theta. If r of pi minus theta is equal to r of theta, then the equation is symmetric about the line pi over 2. So in this case, we are having r equals 1 plus 2 cos theta. So what is r of minus theta? It means wherever we see theta in this equation, we should replace it with minus theta. And so this will become r equals 1 plus 2 cos minus theta. Now, cos minus a is equal to cos a. And therefore, r of minus theta is equal to 1 plus 2 cos theta. And this is equal to r of theta. So this implies that this polar equation is symmetric about the polar axis. Now, the next thing we need to look for is symmetry about the pole. And for symmetry about the pole, we need to look for r of theta plus pi. So wherever we see theta in this equation, we replace it with theta plus pi. So r of theta plus pi is equal to 1 plus 2 cos into bracket theta plus pi. So this is equal to 1 plus 2. Then let me bring this curly bracket. Cos theta plus pi is the same as cos theta cos pi. Then minus sin theta and then sin pi. Bracket close. So this is equal to 1 plus 2 into bracket. Cos pi is minus 1. So this becomes minus cos theta. And sin pi is 0. So this becomes minus 0. And at the end of the day, r of theta plus pi is equal to 1 minus 2 cos theta. But 1 minus 2 cos theta is not equal to r of theta. And therefore, this polar equation is not symmetric about the polar axis. Sorry, it's not symmetric about the pole. So it is. Now let's come to symmetry about the line pi over 2. And to look for symmetry about the line pi over 2, we need to find r of theta, pi minus theta. And this is equal to 1 plus 2 cos into bracket pi minus theta. So this is equal to 1 plus 2. Then I'm opening a bracket here. This is the same as cos pi cos theta, then plus sin pi sin theta. Bracket close. And this is equal to 1 plus 2 into bracket. Cos pi is minus 1, so here becomes minus cos theta. Then sin pi is 0, so it becomes plus 0. And this is equal to 1 minus 2 cos theta. But you see that 1 minus 2 cos theta is not the same as 1 plus 2 cos theta. And therefore, this is not equal to r of theta. It means that this polar equation also fails for symmetry about the line pi over 2. So it is not symmetric about the line pi over 2. So having found all of this, then let's go ahead and then sketch the curve. So our polar diagram has been beautifully drawn here. And what you do is that the values of theta, it starts from 0 to 2 pi. 2 pi is the same as 0. So that is one complete revolution. Then what we'll do is that to find the values of r, we insert the values of theta into the equation that we're given. Remember that we're given r equals 1 plus 2 cos theta. So if you put 0 in 1 plus 2 cos theta, you are going to get 3. If you put pi over 6, you are going to get 2.7. And if you put pi over 3, you are going to get 2. If you put 2 pi over 3, then you are going to get 0. But sorry, there is a box that I miss here, and that is pi on 2. Because pi on 6 plus pi on 3 will give us pi on 2. So if you put pi on 2 into this equation, you will get 1. Then if you put 5 pi, you will get minus 0.7. So we need to keep filling. So if you keep filling everything, then here will become minus 1, minus 0.7, 0, 1, 2, 2.7, and then 3. So this is the table containing the various r values and then theta values. So let's come here and plot it on the curve. So we are starting from 0 degrees, and here is pi on 6. Then here is pi on 3. We are adding units of pi on 6 to each successive angle. So here will be pi on 2. Then we have 2 pi on 3 and 5 pi on 6. Then we have pi here. We have 7 pi on 6. And here is 4 pi on 3 and 3 pi on 2, 5 pi on 3, 11 pi on 6. Then we'll come to 2 pi, which is the same as 0. However, we know that from the r values, we have 0, 1, 2, 2.7, and 3. So here is 0, 1, and here is 2, 2.7, it's here, and then 3. Or if we come here, 0 and 3, this is 0, and then 3 is the outermost. So 0 and 3 is here. And then on pi on 6, we have 2.7. So this is 2.7. Then pi on 3, it's 2. So here is 2. And then pi on 2 is 1. So here is 1. Then 2 pi over 3 is 0. So if we come to this point, then here it's here. 5 pi over 6 is minus 0.7. Now you see that down here is minus 1. And then here is minus 2, minus 2.7, and then 3. So minus 1 is less than, minus 0.7 is less than minus 1. And therefore this will be a little bit less than minus 1. So let's assume that it is somewhere here. And then pi is minus 1. So this is pi. Pi is minus 1. And that is here. At this point, let's draw the curve that we've plotted so far. So if we join these points, this is how it will look like. However, we have already established that this graph is symmetric about the polar axis, and this is the polar axis. So it means that what is here, we need to draw a symmetry on top. And this graph that is here, we need to draw a symmetry at the bottom. And therefore, in drawing the symmetry, we need to draw the same arc like this on top here. So using symmetry rules, then the one at the top is going to look like this. And then using symmetry rules, this one about the polar axis is going to look like this. So this is how our curve is going to look like finally. And this is what is known as a lemma with an inner loop. Graph the equation r equals cos 2 theta. So first thing, let's determine the symmetries. So let's find the symmetry about the polar axis. And with symmetry about the polar axis, we need to look for r of minus theta. And this is equal to 2 cos minus 2 theta. And then 2 cos minus 2 theta is the same as 2 cos 2 theta, which is the same as r of theta. So since r of minus theta is equal to r of theta, then it means that this equation is symmetric about the polar axis. Now let's also look for symmetry about the line pi over 2. And for symmetry about the line pi over 2, we need to look for r of pi minus theta. Let me write it here. R of pi minus theta. And that is equal to 2 cos into bracket 2 theta minus 2 pi. This is equal to 2 cos. So let me bring this bracket. Then cos 2 theta minus 2 pi is the same as cos 2 theta cos 2 pi, then plus sine 2 theta sine 2 pi. Now, what is the result for this? Cos 2 theta is, so cos 2 pi is equal to 1. So this becomes 2 into bracket 1 times cos 2 theta is the same as cos 2 theta. And then sine 2 theta is equal to 0. So this is equal to 2 cos 2 theta. And it is the same as r of theta. And therefore, it means that this equation is also symmetric about the line pi over 2. And for symmetry about the pole, what we need to do is to look for r of theta plus pi. And this is equal to 2 cos 2 theta plus 2 pi. And this is equal to 2 into bracket cos 2 theta plus 2 pi is cos 2 theta cos 2 pi, then minus sine 2 theta sine 2 pi. Now cos 2 theta is 1, so this is equal to 2 into bracket cos 2 pi is 1, so 1 times cos 2 theta will give us cos 2 theta. Then sine 2 pi is 0, so here become minus 0. And this is equal to 2 cos 2 theta, and that is equal to r of theta. So it means that For this equation too, it is also symmetric about the pole. So this equation passes for all the symmetry tests. It is symmetric about the polar axis. It is also symmetric about the pole, and it is symmetric about the line pi over 2. There are times that the equation may not be symmetric about the pole, nor the polar axis, nor the line pi over 2. However, when you finish sketching the curve will show that it is actually symmetric. So those are the curves that defy the rules that we use to test for symmetry. We have our polar graph beautifully drawn here, and this is our table containing theta and the r values. So what we need to do is that for each theta value, we need to find the corresponding r value by inserting that theta value in the equation that was given, which is r equals 2 cos 2 theta. And if you do that, for 0 degrees, you get 2. For pi on 6, it's 1. For pi on 3, it's minus 1. 1 and then 2. So these are the values of r for the various angles. So we are starting from 0 to 2 pi. So here is 0, then we are adding steps of pi over 6. Then here's pi over 3. And here's pi over 2. 2 pi on 3. And then here's 5 pi on 6. Here's pi. 7 pi on 6. 4 pi on 3. 3 pi on 2. 5 pi on 3. Then 11 pi on 6. But if you look through the value, you can see that we only have 1 and then 2. So here is 0, here is 1, and here is 2. Then here is minus 1, and here is minus 2. So if we come to 0, 0 is 2. So is this point. And then for pi on 6 is 1. So it's this point. And then pi on 3 is minus 1. So pi on 3 minus 1 is here. And this is 2. So if we look at it, you can see that this is one of the diagrams that we can have. And then using the laws of symmetry that we did earlier, we saw that this graph is symmetric about the pole. So it is symmetric about this pole. And then it is also symmetric about the polar axis. And then it is symmetric about the line pi over 2. You can see that with the line pi over 2, this is symmetric. This side is equal to this side. And since it is symmetric about the polar axis, then it means that we can also draw another one here using symmetry rules. So the one here too will look like this. Then you can see that there are 2 points here, and then there's another point here. So we can draw the one for this one too. I made a mistake. It's rather supposed to pass through here. So this is a mistake. And now, since the graph is symmetric about the pole, then I could draw another one here. So this is the importance of using symmetry rules. If you use the symmetry, you don't need to plot all the points. You only need to plot a few points and then use the laws of symmetry to draw the rest of the diagram. And you can see that this looks like a rose flower that has 4 petals. And therefore, this is a rose with 4 petals. Sorry, sepals. Sepals with 4 sepals. So this is how this graph is going to look like.